Good morning, good afternoon, and good evening, wherever you are. Welcome to this GEA Live Facebook event. Today's topic is automatic milking with the DairyRobot R9500. Together with my colleague Tobias, we would like to show you what makes the DairyRobot so special. We have about 40 minutes, depending on how many questions we have in the end. If you have comments, please put them in the section below. We will answer them in the end. If we can't answer all the questions due to time constraints, we will answer them in written form afterwards. First of all, I would like to introduce myself briefly. My name is Michael Behrensen. I'm 54 years old, agricultural engineer. I live in Germany. I have been working for GEA for about 20 years, and I was involved in the development of the RMS from nearly the start on. And now I'm working in the sales support, and I'm responsible for trainings and also for events like this. But to be honest, this is the first Facebook event for me.
Yes, hello, and you can see this written down, my name, but I will repeat it again. My name is Tobias Rüth, and also a warm welcome to the audience from my end here. I am a graduate engineer in architecture. I'm 47 years old, and my GEA career starts in 2008. And over the years, I was all the time more or less responsible for a lot of automation and our automated systems here in our farm technologies division, concepts and standard designs, whatever was needed. And currently I am in the position of the head of farm design. This is more or less our planning department within our division within GEA, and we are responsible for the implementation of our complete systems and equipment in the structural environment. And we start from scratch with the first idea, draft concepts, and up to a detailed plan whenever that is needed after a sold project.
Okay, let's start. We have a lot of stuff to tell. Before we go into the DairyRobot R9500, I would like to tell you something briefly about our background. GEA was founded in 1881. GEA is an international tech company for mechanical and process engineering in the food technology business, and GEA Farm Technologies is one segment of the GEA, and we are coming from Westphalia in Germany and from Search Babson Brothers in the US, which came to GEA in the 90s. So shortly, something to our background. You see that we are in the milking business since the 20s in the last century. So we are about 100 years around. In 1962, we presented our first milking rotary. 1997, our first AMS generation, Leonardo, that was basically an automated parlor with one robot arm for up to 4 boxes. And in 2008, we introduced our second generation, the MR1, that was a 4-box or 5-box system with one robot arm for these boxes. In 1912, we decided to come up with a new generation, which had to fulfill the following points. we wanted to be sustainable, we wanted to be flexible, and we wanted to be set up for the future. So we invented really the strategy totally new. And as you know, us Germans, we like automotive, and we had a close look to the automotive industry. When you look at the automotive industry, a lot of companies have a platform strategy. That means they have one engine which goes, for example, in different car models. Volkswagen, for example, is developing in the moment a platform strategy for e-cars. So we wanted to have a platform for the whole automatic milking portfolio, and we developed our DairyProQ stall unit that is a solid stall unit, and you can see here, it's a heavy-duty stall unit in stainless steel. It's no problem when a Holstein Friesian cow leans against it. We can use this stall unit to put it in to group milking systems. Coming from conventional, we wanted to start with group milking systems. That means you milk a group of cow at fixed times. And for that, we developed an automated milking parlor. And for the parlor platform, we took a rotary platform. This automated rotary is named DairyProQ, and it is available in 28 to 80 stalls. We have systems worldwide running. This is, of course, for bigger farms. We also wanted to have this system available for voluntary milking. That is basically that a single cow decides to go to milking whenever she wants. So there we don't have fixed milking times. And also here we put the DairyProQ stall unit in an automated milking system. And here we have the DairyProQ R9500 as a single box, and as a multi-box system, we are able to place the robot in a row. For those customers which don't want an automated milking parlor on a rotary platform, we also can provide the DairyRobot R9500 as a combination in a milking parlor form. So you see here the circle is now closed. We can offer a lot of choices for automatic milking. It depends on what you want. Let's have a look in the DairyRobot R9500. Here we see the robot from the top, and I will explain the different parts of the robot by going through the milking process. First of all, we start with the cow. The cow enters the milking robot from the side, so we have a sideways entrance and exit. The exit can be also straight, so that is a choice. And I have to start this again, that you can see it. When the cow enters the box, she is identified, and then we index the box individual to the cow size. That means we adjust the box size to the cow. Why are we doing that? When we have the box too big, and you probably know that from example, a side-by-side parlor, when you have the first time a small heifer in a side-by-side parlor, the heifer will stand in front, and then you have to make long arms to adjust the cluster, and you take a lot of time to adjust the cluster, and that makes the cow nervous and you nervous. So offering too much space can be stress for the cow, can be stress for the attachment. So that's why we offer enough space for the cow, but not too much space. Otherwise, the cow might dance tango in the box. Another reason is that with indexing the cow in the box, we have the udder where we want it. So it's always defined at this point, there is the udder, and we don't have to search a long time to find the udder of the cow. So that makes the attachment faster. Then we have a look at our stall unit. And in this stall unit, we have the robot unit. You can see that here. The robot unit is placed in the middle with a counterweight. So the robot unit can float within the robot. And the robot is driven by 3 electrical motors. We really decided for electrical motors because it's a simple, robust system. On that way, we don't have to convert electrical energy into hydraulic or pneumatic energy, and we have no loss of consumption. So on this central placed robot unit, we have our milking unit. And as you can see here, let's have the laser. We have a 3D camera in the system. We were the first ones starting with a 3D camera, and to attach a cluster, we tighten our milking arms, and when we have the cluster attached, we release the arms, and then the milk cup is hanging free underneath the udder. As you can see, also we have no long milking tubes. The cups can't fall on the ground. We have no negative forces on the cups, so it's a really good milking. The unit is placed in the middle. With one turn, the unit is underneath the udder, and then we attach the teat cup. And we call that one and done attachment because we have an inliner everything milking process. That means we attach once, and then we do the cleaning, the stimulation, the pre-milking, the milking, and the dipping inside the cup. So we drive underneath the udder, and then we attach once, and then we are done. With this inliner everything principle, we assure that we have really less movements of the robot arm. That means as a result that we have less movements. We have nearly more than 50% less movements underneath the udder than the competition. Because of that, we have less energy consumption. Because of that, we have less stress for the cow. And because of that, we can attach much faster. So with this inliner process, we also avoid cross-contamination because we have no separate process for the cleaning. When we attach, we have everything is done, and we can assure that we have every time a cleaning, and we are the only supplier which can assure that the teat is always cleaned, because we will not start the process when we haven't attached. So that is also a very important point. As you see, the unit is very compact because we want to use it also as a place divider, and that brings us to the point that we have to make service. And when you want to make service in such a compact unit, you have to make it easy. That's why we put the most service relevant parts in this milk technique module. In the end, in this milk technique module, we have the pulsation, we have all the sensors, we have the valves, and so on. You can take this milk technique unit out, replace it to another one, do the service, and go on with milking, so that you have really nearly no downtimes within the system. When you look at this, here's the milk rack, the milking unit, and the milk technology. The way from the milking unit to the milk technique module to the sensors is not long. And that is a really important point for us. We don't want long milkways for the milk. So let's have a look at the sensors. How do we keep an eye on the milk? When you talk about sensors, you have basically two options. One option is you can take a milk sample. When you take a milk sample, you always need reagents to cause a chemical reaction. And you can do something like that only per milking, not per quarter. And when you take a sample, it's always cost intensive. Yeah, you have running cost for taking a sample. That's why we decided to do everything, every measurement within the milk flow without taking a sample. Also with the sample, you have milk losses, and you have small tiny tubes which you have to clean and to service. So for us, it's very important we do all the sensors and all the sensoric, we do that within the milk flow, we do that per quarter, we do that in real time, we do that continuously, and we can do that continuously because we have no consumables. We don't need any consumables for the process, and because of that, we have no extra cost for the sensors. We do that with robust sensors, which are easy to service. So let's have a look. What do we measure? We do, as I said, we do measure everything on quarter level, and we do a measurement of the milk amount. We also measure the milk amount ICA approved for the milking. We do the measurement quarter-wise for the milk flow, quarter-wise for the milk duration, quarter-wise for the milk temperature, quarter-wise for the milk color, for the milk conductivity, and also for the somatic cell count. We are the only one which can provide a cell count detection by quarter. Sometimes you have a millionaire on one teat on one quarter, and you will not see that in the milking. With our system, you will see, you will detect this millionaire by quarter. Okay, so let's go back to this overview. When we have now harvested the milk, when we have looked at the milk, we can make the decision where to direct the milk. Good milk, calf milk, dump milk. And then when we talk about that, we talk about the receiver unit, and we can have a look in that one. Let's start that. So I have to go back here a bit. So what you can see here, we have two different milkways. We have a good milk weigh. We have a good milk weigh, a good milk receiver, and we have a calf milk receiver and a dump milk weigh. The good milk receiver has only a volume of 5 liters. That means we can't put the whole milking into the receiver. So what are we doing? With a frequently controlled pump, we pump the milk away continuously, and that brings us to the result that we don't have to wait in the end to empty a big receiver. Also, what we want to see is that we have the receivers transparent. I always want to be able to look into a receiver to see, is this receiver cleaned? Also here we look again at consumption. The reason to have this receiver small is also that for a small receiver you need less water to clean, less detergent to clean, less energy to warm the water up. Last but not least, we have the supply unit. You have to supply the robot with water, with energy, with detergent, with disinfection, with dip solution, with pre-dip. And this supply unit supplies the robot with that. To this supply unit, you can connect up to 4 robots. And by doing that, you also have a digression of consumption. With every robot you put, in addition to the unit, you have less consumption per robot. We can also prove that because we are tested independently by the DLG, that's the German Farmer Organization in Germany. Okay, so one point is missing in this, and that is the point human being. Because now we looked at cows to be milked and cows which are milked, and that are 80% of the herd. And this 80% will do 20% of the work. So what is with the rest 20%? That are special need cows. What are special need cows? Special need cows are action cows that are, for example, new cows in the system, cows to be dried off, cows to be treated, whatever. So that's action cows. Then we have transit cows. That means close-up cows, calving cows, fresh milk, cows fresh in milk. And then we have cows under observation, lame cows, mastitis cows, and so on. And these cows will not disappear in an automatic milking system. You have to take care of these cows, especially when you have a look how much work they have, how much work they make. This 20% of the cows make 80% of the work. So we really have to look at this subject that's daily work to work with these cows. So how can we manage this? For this, we have an end frame, and you can see that here, a special place for the operator, which looks like this. You have a really good view on the milking unit, a really good view on the udder. You have a light there you can put on so that you even have a better view, and you can check the udder, you can check the teats, you can check the milk, you can support the cow. If I have a nervous cow in the system for the first time, of course I can attach automatically, but I also can interfere into the milking process. I can stop it, I can calm the cow down, and then I can do a manual attachment like in a side-by-side parlor. Or, for example, I have a cow with an edema. I can really attach this cow manually. And of course, I can treat the cow. Why shouldn't I treat the cow when I have her already in the box? It's really easy to dry off a cow in this system. So we want to be able to train, to milk, to check, and to support all cows of the herd in a central environment with, if possible, one person in an easy way, in a comfortable way, in an ergonomical way, without any risk of injury, without any stress for the cow, without any stress for the human being, without long walkways. You walk already so much during the day without a long walkway for the cow, without additional work. I want to be able to organize things in an easy way. And here we talk about a milk and management center. I want to be able to do that in a central place. And okay, I had this already. So, and here we have now the missing element. We talked about the human, the cow, the technique, and the environment. Now we have to talk about how do we place this system in the barn environment. And at that place, I hand over to Tobias.
Yeah, thank you very much, Michael, for this very good explanation what functionality is within the DairyRobot R9500 and how modular this milking box is. And I want to make some steps back and change a little bit the perspective, because you know that when we talk about an automatic milking system, we always talk about the milking robot, of course. But in the end, this is only okay. It's the heart of the system, more or less. But in the end, it's only a part. So we have to look around and see what's going on around, because when we want to be really successful also in our farm operation, and we want to have good quality milk in our tanks, we need to do something more. And I want to start first with a short explanation, a little bit about the pattern, what's the basic for a system, or maybe also for a design, before we later on step in sample 3D models, where I want to guide you a little bit through the barn and show you the logistic around the DairyRobot R9500 and what the system is about. Yeah. Okay, in the center we have, of course, the milking box, and we heard it already. So we are able to provide a single box system for smaller herds, but we are also offering a multi-box system where several boxes can build a system, or a multi-box system. And of course, we have to place the robot somewhere. And now, when we have a look on what's in front of the robots, of course, we have to talk about the barn. And this is more or less the place where the cows are housed. And this is a sample showing here with a, I would say, freestall barn with several rows, but could be also a different type of barn, or maybe a compost barn, or deep bedding, or whatever. So it doesn't matter. But we have to connect also the boxes with the barn, and that's why there comes the first thing into the game. That is the question that we have to answer about the cow flow. So How is the interface? Okay, the cows have to go to the robots and to the milking system, and they have to do it stress-free, voluntary, so there don't have to be obstacles in the barn. The way has always to be free and something like that. And there we have also different options in combining the robots more or less with the barn. Then we have the chance to choose really, okay, what cow flow do the customer prefer, or what it's better for a cow, or what it's maybe more labor efficient for the people that have to work with the cows. And there we have several options, starting with the free cow traffic. Then we have a semi-guided cow traffic where we partially guide the cow in the barn to save labor, as I already said, and afterwards we have also the chance to totally guide the cows in the barn. Next point, we have to go on the backside of the system, and Michael a few minutes ago talked already about that, because the biological side of the cow and also the lactation cycle from the cow is always the same, and this is not different compared to a conventional system. So we have also some cow actions, and we need to dry off a cow. There's a complete transition phase we have to take care on. The cow has to calve, has a good start, and coming back to the system, and all these things that play a key role in regards to having good and well performing cows, and there we need to define really the separation area and the sort pens on the backside of the robot, and key to all this is the decision on the herd management, because the herd management is more or less giving the system an impression of how the operator or the customer or the farmer wants to work in the end with the system. So there are also several options. You can do it in a basic system where you really focus on really only on the milking cows, and all the rest of the herd is managed somewhere else. But step by step, you have also the chance to really to put cows in addition to the system, have some special need cows, for example, or fresh cows near to the system that already these starting cows can have access to these milking boxes, and that these cows also can be milked with a robot. So there are different options, and I highlighted now in yellow here the combination I want to show you and explain you as a sample a little bit, where we then have the chance to have a closer look in. There will be popping up in a few seconds a free system with a multi-box solution, and also on the backside more or less a basic plus herd management system. So we go now in, and like you see here, we have here I would say an well-known and famous 3-row barn, and before I go closer to the logistic around the robots, I step in a little bit here, because for the barn itself, or the place where the cows are resting and the cows get fed, there is the first priority is always having a good climate, cow comfort. In an AMS is always really essential to give the cows a little bit more space, like we know it from the conventional barns. So the cow has to come from also here, from when we go to the left to the right a little bit. So from the end of the barn, the cow needs to have a really smooth way to the system, and afterwards back again in the barn. So this is really something we have to keep an eye on, and then that's also these measurements of LAs and crossovers and everything is really fitting to an automatic system. So when we have then a closer look, and I make a little bit of rodeo today with you here, and we have a little bit of deep dive here in that area. You see what is also needed for every system is a waiting area in front, that the cows that are waiting for milking when the box is already already occupied with a cow, then we need a waiting area in front, and this also needs to be, yeah, as much as the system needs it, more or less. We have here, like you see, we have 2 robots in a row. So this is a 2-box system, and the good thing is we can make out of 2 boxes only one milking system, because we add here in front the so-called guided exit frame, and this gives us the opportunity to really guide cows out of 2 boxes in one direction away from milking, and this is nothing else than guiding fencing, a little bit of guiding fences, and with the intelligent gate control here, that gives us the chance to really to make one system out of 2 boxes. And on the back side here, we see there's another feature is here. This is it's a normal swing gate, and this could be pushed by the cows themselves, that they can enter the box here from the front side. You see that here the cows can go in here from that end, but when from the back side a cow is coming, this cow has also the chance to get directly access into the first box. So on the other side, on the other end, we have, I make a little bit of top view, that we have really a good view on a logistic here, and here at the end of the guided exit frame. So all cows out of the 2 boxes will go here through a sorting gate, and this sorting gate decides then, okay, the cow can go back to the group, or this cow has to be sorted out by a special criteria or time-related reasons or whatever. And you see here another options comes in, because you see here there's a second sort gate, and this is like an automated switch in this situation. So here we have another chance to really decide, okay, is it a cow that has to go to the right? So there's a special reason, because the cow is maybe a special need cow or a lame cow or whatever, or is it because we have to do some cow action treatments or whatever? Then the cow is like you see here, guided then to the left side. When we go a little bit back again here and have a look on the back side here, I turn it around a little bit to have really a nice view in the area on the back side here. You see also that we have here this temporary sorting pen for the cow actions with some cubicles. This is also really important when a cow is sorted out, and this cow is coming maybe early in the morning or late in the night, and I know I have to sort this cow out. So this cow has to lay down and has water has to be available, and also feed and everything. So this is also really has to be really good equipped here on from this perspective. But you see here, this is for a short-term stay, more or less, and here I added also an option here. You see that this is a treatment box, and this gives us also a little bit more opportunities to really fulfill all these things that have to be done in regards to the health of the cows. And you see here in the front we have also some feed fences, self-locking feed fences. You can fetch a cow here, of course, but you are also in this setting, you are also able here, you have some fences that are really helpful and useful, because here you are able to really out of this area to bring a cow, maybe also only with one person, to bring that cow in the box, make some actions, and afterwards guide the cow back in this area. Or here on the upper side here, when the orange gate is also closed, you are also able to really to guide this cow directly also to milking when you want to check also, like Michael was already explaining, that we have also the chance to really have access to the cow in the box, so we can also have an observed milking when there's a need to. Here, the bigger group pen is like I mentioned already, maybe for the special needs cows, or when the person in charge or the manager wants to integrate also the fresh cows early to this milking system again, or early in the AMS barn again. So from here, I start to make a rodeo again for you, because I think this is very impressive as well. Here you see that from this pen, the cows have voluntary access here to the milking system. So means, I when I really have cows I have to train, or really, like I mentioned, these fresh cows, these cows are able to do really their own way to milking. I don't have to spend labor and workload to these cows, and I know, and this is also because we have these two sort gates here at the exit. I know that when the cow is entering the box from the backside, the cow is automatically sorted out again to the pen. So this is a huge benefit in regards to training and everything. So I can spare a lot of workload for this, and I can here manage the cows more compared to a simple system where I only have maybe a temporary sort pen here. You see here at the side are a block of rooms, so it's not filled today, but this block of rooms is normally the equipment room, milk storage room, maybe an office or staff rooms or whatever. This is here at the side, and you see also when I zoom in here, you see there's an only a short connection. So here you see there's only one step here, so only one position where I have to cross the cow flow or the cow traffic in the end, and I enter here the robot installation room, and you see this here. There's a good and really clean and safe working environment. I have here a large pit around all boxes. The boxes are standing on a plateau more or less. This is good to have really this good view on the other when there's a need to, but also for the technicians and the service guys, it's also helpful when they don't have to go down on their knees to do special things here, especially here at the receiver unit where a lot of hoses and valves have to be checked here. Of course, this is still highlighted block of rooms could also be here in front on the gable side. This is also possible. So there we are also very flexible in regards to the installation, because we have, of course, like every supplier have some technical limits, but these are things we can cover easily, and so it gives us really more opportunities on the farm to really react on a existing situation or on the logistic on site on the estate in the end. I switch over now, and I have two more samples for you, and this should show you how flexible and also how modular we are also with our DairyRobot R9500, because when we have here a look here, this is only a compact single box system. You see here, this is a small and compact system, but the overall idea and the overall logistic is nothing else than we saw before in a quite bigger installation. So we have also here this sort gate. In this case, it's a shorter one because we don't need an additional ID identification here, because this gate is box controlled. So the system knows when the feed trough is open, the cow has to be sorted out or can go back to the group. And here on the back side, we have also here the swing gate. So this allows us also that cows can enter from the back side here, that system. And also one feature is here, and that's why I want to show you this as well. You see there, we have no big pit around this box here. So this is only a small pit on the backside where we need access to the cow's udder, and this could be done for building reasons. So when there's an special ground or soil is maybe with rocks or whatever, so I cannot dig too much into the ground. So this could be an option, and also this is a little bit cheaper than building a complete pit around. So maybe I make here and then. Oh, sorry, I go back a little bit and a little bit of roller coaster feeling here with you, but here I want to zoom in that you have a feeling also how it looks like from the other side, from the operator side. And here you see also with the end frame, and you can have a look here through this end frame and see the cow and the udder, and can as well, like we saw on the sample before, we have a really good working environment also when we are talking about these smaller installations. So last but not least, I want to switch to a bigger version, and this is also very interesting to show, because here we zoom in again. Here you see we have 3 boxes in a row, and also in combination with this guided exit frame in front, we can offer for interested customers really a 3-box solution, and we don't have to puzzle together a single or a double box installation, or we have to be a little bit how can I say it, having not the optimal solution for 3 boxes, so we don't have to make big compromises here. So we can offer a 3-box system here with one installation rule, with one working spot here, and Michael was in the first part was already mentioned that here you see our supply units hanging at the wall. We are able to really supply here these 3 boxes, and we are also even could support 4 boxes in a row. That would make no difference at all. You see here, this is a defined waiting area, so a permanent waiting area. And this is related to the fact that we have here a pre-sort gate. This sort gate is really helpful, because only the cows that coming out of the barn will be guided into this waiting area that has the right to be milked. So this is very good to really control a little bit the performance at the system, at the boxes, and also gives the cows a little bit less stress here, because the other cow traffic is going here beside this area, and so there's no pressure here in this area, so a cow can have really a relaxed access to the boxes. And what is also a benefit from this installation, when we have a system like this, we talk about the semi-guided system when we add a pre-sort gate. we prevent to have this empty visit at the boxes. You know, you have always annoying cow in the herd that is going in the box again and again, and to have a rest here and the rest there of concentrate or whatever, or licking where it makes sense or not. So you can prevent that, because also with this kind of installation, every cow is after milking is directly sorted out via this exit lane and going back, either back to the group or is going here back. You see this again with this double sort gate installation, is going back again on the back side, or will be sorted out. Okay, there I'm at the end of my part here of this event. So hopefully you get an impression a little bit on the logistic, and have a feeling, and also the understanding of that the milking box is very the heart of a system, but to really to have a good working automatic milking system, where you are able to really to not only milk your cows, but also to manage your cows with that system, that you have a lot of opportunities. There's a lot of flexibility with our DairyRobot R9500, and this gives us really really a handful of options that we can cope a lot of demands from customers all over the world. Okay, then thanks from my end up to now, and I will give a pass now back to Michael Berenson, and he will maybe finally close our session now.
Yes, I catch a ball. So as you see, we have not much limits. We have a big toolbox we can offer you. We can offer all cow traffics. We can offer all milking systems, group milking, voluntary. We can offer all combinations. It's depending on you. What is your goal? What do you want? What fits to your barn? How do you want to manage the barn? When we come to you, we always come with a lot of questions, and a good sales guy should be able to listen to your wishes. Yeah. So we can create something together that you have a good solution for the next decade, because a milking robot is a big investment. Okay, at that point, we are far over the time, I see. I hand over to Lilian, and we should come to the questions. Hello,
Yes.
Lilian.
Hello. Hi, Michael and Tobias. Yes,
Hi, Lilian.
thank you for your expertise on this really, really interesting and broad topic. I mean, as we all have learned today, that it's not only up to the dairy robot and the technical details, but also to the farm design. So thanks again, Tobias, for this very, very interesting explanation.
Yeah.
I'd like also to thank you for giving me the opportunity to ask a few questions on behalf of our journalists. As you know, I've also invited our trade press to this event, and thanks for your interest in our session. For those who don't know me yet, my name is Lilian Schmanstra, and I'm responsible for press relations at GEA Farm Technologies. I will also moderate the questions from the chat that we received so far. This, of course, have priority, so please don't hesitate to ask us now or later on. We will come back to you in a written form, or maybe, I mean, it's the time. I mean, we've now more than 15 minutes right now, so please. Please thank thanks for your understanding that we don't can come back to every question today, but we will come back to it later on. A first question, and thanks also for Alexandru. He's very active in the chat that I've seen, and he's answered many questions. But I'd like to come back to one of the questions, which is how do you separate the bad milk, and how does the system work? I mean, at some point it has been answered by your explanation, Michael, but maybe you can come back again to the question, is there a possibility that it goes all wrong and that bad milk goes to fridge?
No, that's the first point. We go with this inliner everything process since 20 years, and we have a lot of experience. To control a process like that is no rocket science. We are professionals in process engineering, so that works pretty good. So if, for example, if we detect bad milk, for example, if we have blood in the milk, yeah, this milk will be dumped automatically from the start on. Yeah, so there's no doubt this milk will be dumped straight away. If we have higher cells, for example, we will give you an alarm, and then you can decide what to do. You can always interfere in the running milking process. For example, if you are feeding the calves and you have not enough milk, you can quarter-wise select milk ways, and for example select 2 quarters to the calf milk. Yeah. So if you have a treated cow, mastitis cows with antibiotics, you can say in the herd management system before, okay, this cow has to be milked in the can or has to be separated. So that's also no worries.
Yeah. Okay. And another question was that the question about fat and protein sensors. I think it's meant that is there a possibility to integrate such a sensor in the system?
Definitely, there is a room to integrate more sensors in the milk technique module, but it always has to make sense to integrate sensors. And the milk and fat protein sensors, which are available today in the market, are not reliable enough. That's one point, and the other point is that that way it doesn't make much sense. So of course we would be happy to integrate a fat and protein sensor, but it has to make sense in the end. In the moment we don't have one available.
Okay, thanks. And the next question for Tobias, do cows have a preference for a left or right robot?
You're unmuted.
Yeah. I have to unmute myself. Sorry for that delay. Yes, this is always a good question, but I think there's always a way that the cow can choose whatever box the cow wants to go to. But like I mentioned already, there's also a training aspect, because when it's like you can compare it to a conventional group parlor. When a fresh heifer is learned only on one side of the parlor, she will probably go all the time to that side of the parlor. So that's why it's when you have a left and right box into the system, there could be so there's not a yes or no, but there could be a difference in the capacity on the robots, and also there is also then the question, okay, when a cow can only be trained on a right-handed box but I have only a left-handed box, so you see there is a big variance of dealing with that. So when you want to make it really professional, you have to say, okay, when I have a left and a right hand box, you have to train the cow on each side, so that the cow is knowing, okay, I can come from the left and come from the right, but this is also then a reason from a labor efficiency perspective. That's why we say put all boxes in a row. The boxes have the same orientation, so it's easier for the cows to learn, and it's also easier for the people that work with the system. So there is no better or what's best or what's wrong. So I don't want to judge about that, but there are some points that really have to be critical, seen on that, and yeah, and hopefully that answer helps also the one that asked for that.
Okay, thank you. Maybe two last questions because I'm near to 1 hour talking, but yes, thank you for staying still with us. Is there a new software as follow-up for the dairy plan? Is one of the questions.
Yes, a new software is coming up. We know that our dairy plan software is a very good software. We can offer with dairy plan a lot of stuff, but of course we know that dairy plan is old-fashioned. People don't like the overview of that on the screen anymore. We have a new software coming up. It's DairyNet. It's called DairyNet, and we will release this software in May in the first countries for robotic milking, and then we will go on country by country. And that is, of course, a state-of-the-art software where you can analyze everything and so on.
Yeah, exactly. By the way, if you would like to get some more information about the upcoming DairyNet, please don't hesitate to visit us at GEA.com. In German language, you can see the full press release that we released 2 weeks ago or last week. But for the upcoming countries in Europe and worldwide, you have to wait, unfortunately, a bit more, but you can see when you are up in the rope. I've got one last question, and this is a question for Michael, because I know this this is a question that we are often talking about. I was asked how many cows can be milked per day with a dairy robot.
I like these questions, and
I know.
I can also answer this question. It depends, and this answer, of course, will not give the answer. I can give an example. My brother lives about 210 k's away from me. If I'm going to visit him, I can go with my car. My car goes in max 220 k's, so I could say I can drive to my brother in less than 1 hour. Yeah, but that will never be the case, because I always need much more than 2 hours, because there is traffic on the roads. I have traffic lights, I have trucks in front, I have speed limit, I have not always an autobahn, and so on. So it depends on a lot of things, and it is yeah, we don't want to promise something we can't stick to. So it really depends on the milk amount you have with your cows. It depends on how many milkings you want to realize. Of course, you want to milk the fresh calf cows more often. It depends also on the stable situation. It depends on the milk flow. The normal milk flow here in Germany is 2.1 liters per minute, and that goes up to more than 4. So it depends on a lot of factors. So in average, you can say around 60 cows, no problem. I like more to talk about kilos per box and day. And when you look at that, you see also a lot of promises in the field. For example, 3.5 tons per box and day. If you really do an easy math here, then if you divide 3,500 kilos by 60 cows, then you end up by 58 liters per cow. Yeah, and when you talk about this amount, you talk about Formula One. Yeah, this is not a normal setup anymore. You can only do this with a lot of effort, with a lot of people, with a lot of amount of money, and it's not economical. So we can reach with our system. We have farms which reach about 3,000 kilos per box and day, but not every day. Yeah, and that
Mm-hmm.
are really farms which are set up in optimum. They have an optimum management. They have high producing cows with a high milk flow, with a super barn, and so on. So
Yeah.
when you look in, and that maybe I end with that, when you look in average in Europe, then you look at 1,800 kilos per box and day. And that is realistic in the moment. So have a look to your cows and your herd, and we can calculate with you together how many kilos you can do per box a day and how many cows you can do per box a day.
Okay. Yeah, thanks again very much. And I think that due to the advancing time, we unfortunately have to come to an end now with all the questions. But you can be sure we are coming back to you afterwards, and no question will be left unanswered. Feel free to contact us also afterwards directly, or post some more questions down below in the chat channel, and we will come back to you as soon as possible. Yes, thanks from my side again to Michael and Tobias, but it's now your last word. Thanks from my side. Have a nice day and stay healthy, everybody.
Yeah, thank you. It was a pleasure. Hope you liked it. And we would like, after this experience, to do more sessions, really. Tobias, what do you think?
Yes, I fully agree because I had also a look to the audience. There are a lot of people that are watching this live session. So thank you, everybody. Thank you, every follower, every GEA supporter, and also guests. And it was a pleasure for us to really also present you our work and our idea of the automatic system when you want to go with GEA Farm Technologies. And yeah, I think we keep in touch, and we see us in the next session. Yeah, and for now I can say bye, and like Lillian said, so stay healthy at these times, and take care on yourself, and yeah, have a good rest of the day, have a good evening, have a good morning, or whatever, wherever you are. So
you are.
Yeah. Thank you.
Okay, thank you. Have a nice evening.
Thank you.
Bye
Goodbye.
Bye bye.